All right, welcome back. So in this video, we are going to work on a couple examples that deal with simplifying expressions using trig identities. As a reminder, I've put the three main Pythagorean identities that we're going to be working with, but you should have in the back of your mind the reciprocal identities, secant being 1 over cosine, etc. So let's start. Example 1 says something like simplify. Simplify always means make easier to read, break it down, ideally into one or fewer terms. So simplify cosecant squared theta minus cotan squared theta. Okay. Well, the first thing I notice is that I'm dealing with cosecants and cotans. I have some identities related to cosecant and cotan. They're both squared, and so if you notice, all of these are squared, and so you will need a squared in order to use the Pythagorean identities. So I see cosecant squared here, and I see cosecant squared here. I'm going to replace cosecant squared with cotan squared plus 1. So instead of cosecant squared, it's going to be cotan squared plus 1 minus cotan squared. Okay, well, now I have a cotan squared minus a cotan squared, so those are going to subtract out, and this is going to simplify nicely to just 1. Who would have thought? Cosecant squared theta minus cotan squared theta is always going to be 1. Let's try another one. Let's try simplifying. So simplify. This may be a little easier. Sine of x. Remember, x and theta interchangeable, times cosine of x times secant of x. Okay, well here we have sine x times cosine x, and secant is 1 over cosine x. Well, here cosine over cosine cancels out, and we're left with just sine of x. Not too bad. The third example we're going to do involves some factoring. And in the next video, we're going to talk a little bit more about factoring, but let's introduce this first. So simplify sine of x times cosine squared of x minus sine of x. You can actually do this problem without factoring, but it's a little neater if we do factor first. You'll also notice we have a sine and a cosine squared. Again, keep in mind that in order to use any of these Pythagorean identities, you need squares. So we can replace this cosine squared, but we cannot replace these sines. I'm going to factor out the sine of x. So I get sine of x times cosine squared of x minus 1. And now if I look towards that first identity, well, I don't see exactly cosine squared minus 1. But if I take the 1, bring it to the left side, take the sine squared, move it to the right side, you'll find that cosine squared minus 1 is equal to negative sine squared. And so this simplifies to negative sine squared of x. I can multiply sine times sine squared to get negative sine cubed of x. And so there are some examples about how to simplify expressions using these Pythagorean identities, as well as a reciprocal identity shown in example 2.